Unfortunately, the $100 million never arrived. Those are the words of Gareth Vale, professor of physics at Pacific Coast University at Fairhaven, and the lead architect of the technological concept behind Frontier Lightsail. They were spoken in an interview with American Science Review in September of 2025. Vale had been involved in the project from the very beginning. It was his group that developed the concept of a laser sail probe meant to fly to Alder Centauri. It was his laboratory that had been expected to serve as one of the main recipients of funding. The project has been frozen indefinitely. There was no official announcement, no press release. The project website still exists. Its social media accounts have been silent since 2024. That is the real story, not the mechanics of failure, the mechanism of disappearance. Let's go through the record. April 12, 2016. The observatory at the Empire State Building. No, not there. Skyline Crown Observatory in Kingsport. A press conference with two names in the headline, Adrian Mercer and Martin Hale. A third participant was listed as well, Ethan Calder, as a member of the advisory board. That mattered for media reach. 3 recognizable names, maximum audience. The announcement, Frontier Lightsail, a $100 million initiative. The goal, to develop nanoscale probes weighing a few grams, equipped with a laser sail capable of flying to Alder Centauri, the star system nearest the day star, 4.24 light-years away, at 20% of the speed of light. Flight time, about 20 years. Hale said at the press conference, "Earthmere is a wonderful place, but it is not eternal. Sooner or later, we must look to the stars." Mercer said, "It is an ambitious goal, but physics allows it." Notice the wording, not, "we know how to do this," but "physics allows it." Those are fundamentally different statements. What exactly did Frontier Lightsail promise? The $100 million was not for a flight to Alder Centauri. It was for proof of concept. That is, for the development and testing of technologies that might someday be used for such a mission. The distinction is substantial, and it was there in the press release, though not in the headlines. An actual launch to Alder Centauri, by Mercer's own estimate, would require $5 to $10 billion. That is 50 to 100 times more than the announced sum. Who decided to present 100 million as the number for the media? The answer is obvious. 100 million is a large, persuasive figure. 5 billion invites the response. Why not go straight to Mars on private money while you're at it? Different narratives, different media resonance. This was not deception, it was PR, but PR that created a false expectation in the audience about the project's true scale. Now, what happened between 2016 and 2025? In 2016, after the announcement, Mercer hired Colin Drake, former director of the Redwood Aerospace Research Center of the U.S. Space Agency, as executive director of Frontier Lightsail. It was the right decision. Drake had real experience managing space programs. Research began. Funding went into small university grants, studies of laser sail technology, materials science for ultralight membranes, optics for phased array systems. Vale's group at UCSB received about $4.5 million for direct research. Those figures are confirmed from Vale's own publications. And here there is an important nuance the media largely ignored. In his interviews with American Science Review, Vale clarified that his group received 2 grants from Breakthrough, one for $116,000 and another for about $80,000. In total, roughly $200,000 over 8 years. That was significantly less than what the U.S. Space Agency had allocated to his group for similar directed energy research. Breakthrough contributed less than 5% of our program's funding in the end, Vale said, so it was a small fragment. But in public perception, the whole program was a breakthrough program, and that's simply not true. The total $4.5 million amounted to 30 contracts distributed among different groups, broken into grants of $100,000 to 150,000 each. That is the scale of a modest academic grant, not the scale of a program meant to change the history of astronautics. Another detail adds context. When American Science Review was preparing its feature on Frontier Lightsail in early 2025, journalists contacted Drake and Crow. Both declined to be interviewed. A representative of the Frontier Laureate Foundation said that an official report on the project was expected by spring 2025, and that Breakthrough would provide it to the magazine. The issue came out in September. The report never appeared. That in itself is telling. A promised report on a project that had never officially been closed was still unpublished, even by the time the subject became public. Walter Sloan, brilliant physicist, one of the fathers of Project Thunderwake, the nuclear rocket program, attended a conference not long after the Frontier Lightsail announcement in 2016. When asked what he thought, he said, "No, it's foolish, but the probe is interesting." Sloan was right on both counts. In 2018, Hale died. March 14th. He was 76. Hale never lived to see a single significant technological result from Frontier Lightsail. In 2021, according to Harbor City University, which had participated in one of the research programs, funding for that line of work ended. By 2024, the project had effectively stopped. No public events, no new grants, no new publications under the project's name. In September 2025, American Science Review published an article under the headline, "The Quiet End of Frontier Lightsail." That is where Vale's quote comes from. He said it plainly: the money never came, and the project had been frozen indefinitely. No official announcement followed from Frontier Horizons Initiative, Mercer's organization. That in itself is data, not neutral data. Let us examine why the technical barriers proved insurmountable within the stated budget. The first barrier, a 100 gigawatt laser array. The physics of a laser sail is understood and not disputed. Photons exert pressure on a surface. If the sail is light enough and the laser powerful enough, an object can be accelerated to a significant fraction of the speed of light. The principle works. The problem: 100 gigawatts is roughly 10% of the total electrical output of the entire power grid of the United Commonwealth. For comparison, the largest power plants in the world produce 1 to 2 gigawatts. What is required is a network of lasers with a combined power of 100 gigawatts, synchronized into a single beam with nanosecond precision. This is an engineering challenge on a level far beyond anything that currently exists. The second barrier, military use. A 100 gigawatt laser is a weapon. It is an anti-satellite weapon, a means of striking targets in orbit, a system that immediately raises questions about international treaties on weapons in space. The Outer Space Treaty of 1967 does not explicitly forbid such systems, but it creates a legally ambiguous territory. Any state regulator asked to authorize the construction of such a system immediately asks about dual use. And not without reason. This is not a theoretical problem. It is a real obstacle to obtaining permits. The third barrier, the nanocraft. The mass of the probe must be a few grams. At that rate of acceleration, even a few grams is a great deal. Ideally, less than a gram. The nanocraft must carry a camera, a transmitter, a power source, and attitude control systems. That requires a level of electronics miniaturization that no one in the world has right now. Chips manufactured in 2016 were tens of times heavier than required. Progress is being made, but more slowly than the planners optimistically assumed. The fourth barrier, the sail. Several square meters in area, a mass on the order of grams, resistance to 100 gigawatts of laser radiation for several minutes, and the ability to remain intact while accelerating from 0 to 20% of the speed of light. Not one known material meets this entire set of requirements at once. Research into graphene and other two-dimensional materials continues. Not a single suitable material has been produced. The fifth barrier, communication. When the probe reaches Alder Centauri in 20 years, its signal will still need another 4.24 years to get back. In total, 24 years there plus 4 years back, 28 years from launch. The transmitter on the probe must be powerful enough for a signal from 4 light-years away to reach Earthmere. At the received signal power typical of a few grams of electronics, that requires enormous ground antennas. With an area far greater than existing radio telescopes, that is another engineering problem. Separate, additional to all the others. Taken together, 5 barriers, not one of them overcome. $100 million for proof of concept was realistic for studying individual aspects. But for overcoming all 5 barriers at once? No. Gareth Vale knew this from the beginning. He spoke about it at scientific conferences. But in public announcements, that context was gently omitted. It is worth pausing here on the economics of the laser array, because cost is the main barrier that usually does not receive proper attention in media retellings. In 2016, the cost of laser power was around $100 per watt. At 100 gigawatts, that means $10 trillion for the lasers alone. For Frontier Lightsail to be realized, that figure would have to fall to a few cents per watt, a reduction by a factor of 2 to 3,000. Vale and other technological optimists pointed out that historically the cost of laser power had been falling by about half every 18 months, much like Moore's law. If that trend held, then over 30 years the price would fall enough. But that trend is not guaranteed. It worked in commercial optics, telecommunications, industrial lasers. A laser for Frontier Lightsail is a different class of power altogether. Extrapolating across 12 to 13 orders of improvement is a strong assumption. Even so, in material science there has been real progress. In 2025, researchers from Briarfield University and the Northbridge Institute of Technology published a paper on ultra-thin sails optimized with artificial intelligence. Silicon nitride sails only a few nanometers thick are one of the few genuine technical achievements within the scope of Frontier Lightsail's ideas. That is science. That is a real result. But it is not an interstellar probe by 2036. It is an understanding of how to make an ultra-thin coating that may someday become one of the 10 necessary components. From an email by Colin Drake that became known later, the project is frozen and work is underway to transfer individual parts to other organizations. A diplomatic phrasing for what is effectively a shutdown without official acknowledgement. Now, about Alder B, the target of the mission. In August 2016, 4 months after the Frontier Lightsail announcement, Natural Science Journal published a paper by Adrian Mercer of Queen Eleanor University. The discovery, an exoplanet in the habitable zone of Alder Centauri. Designation, Proxima Centauri b. Mass, about 1.07 Earth masses. Orbital period, 11 days. The media wrote, Earth 2 has been found. A potentially habitable planet around the nearest star. The perfect target for Frontier Lightsail. The real picture is more complicated. Alder Centauri is a red dwarf, an active star. A powerful flare, an outburst, roughly every 50 days. In 2017, an especially powerful flare was recorded, an order of magnitude brighter than a typical one. The approximate orbital period of Alder B is 11 days. That means it lies very close to the star. So close that it is most likely tidally locked, one side always facing the star, the other always in darkness. Like our pale moon always shows one face to Earthmere. The problem is this. With tidal locking, one side may be subjected to extreme heat, the other to extreme cold. Without a dense atmosphere and oceans to redistribute that heat, neither side is suitable for life as we understand it. In addition, Intense X-ray and ultraviolet radiation from flares can strip away an atmosphere on geologically short timescales if the planet's magnetic field is too weak. We have no data on the magnetic field of Alder B. It is too small and too far away. Models published between 2017 and 2020 show that under the typical activity of Alder Centauri, the atmosphere of Alder B could have been completely stripped away in a few 100 million years. The system's age is about 5 billion years. If the models are correct, any atmosphere there has been gone for a very long time. That does not mean there is no life there. Extremophiles beneath the surface, in cracks within the rock, perhaps. But an Earth-like planet was a journalistic interpretation, not the scientific position. The goal of Frontier Lightsail is to reach a system that probably does not have the conditions for life as we are looking for it. That does not make the mission meaningless. The first flight to another star would be a revolution, regardless of the outcome. But it changes the context of the announcement. Adrian Mercer and Martin Hale in 2016 spoke of a search for signs of life. By 2020, it had become clear that searching for signs of life there would be difficult. The star is too active, the environment too harsh. Now, how exactly large scientific projects are frozen without any official announcement? This is not unique to Frontier Lightsail. It is a pattern. The U.S. Space Agency shut down the development program for the Aurora nuclear rocket engine in 1973 without any public announcement of closure. They simply stopped the funding. The program faded out. Signal Search Home, a volunteer distributed computing project, was suspended in 2020. Officially, indefinitely. In practice, closed. There was no announcement of closure. Frontier Lightsail follows the same pattern. No official closure, because official closure is an admission of failure. And admitting failure requires explanations. Explanations are inconvenient. A quiet fading away is easier. No announcement, no questions, no accountability. Who made that decision? Adrian Mercer and his team at the Frontier Horizons Initiative. It is a private organization, not obligated to report publicly. Formally, that is their right. But Martin Hale publicly associated his name with the project. That created a public contract, informal, but real. When a project is closed without announcement, that contract with the audience that followed it is broken. Names, dates, documents. April 12th, 2016, the announcement in Kingsport. August 2016, the discovery of Alder B in Natural Science Journal. March 14th, 2018, Hale's death. 2018, the discovery of Alder B in Natural Science Journal. March 14th, 2018, Hale's death. 2018, the discovery of Alder B in Natural Science Journal. March 14th, 2018, Hale's death. 2018, the discovery of Alder B in Natural Science Journal. March 14th, 2018, Hale's death. 2018, the discovery of Alder B in Natural Science Journal. March 14th, 2018, Hale's death. 2018, the discovery of Alder B in Natural Science Journal. March 14th, 2018, Hale's death. 2018, the discovery of Alder B in Natural Science Journal. March 14th, 2018, Hale's death. 2018, the discovery of Alder B in Natural Science Journal. March 14th, 2018, Hale's death. 2018, the discovery of Alder B in Natural Science Journal. March 14th, 2018, Hale's death. 2018, the discovery of Alder B in Natural Science Journal. March 14th, 2018, Hale's death. 2018, the discovery of Alder B in Natural Science Journal. March 14th, 2018, Hale's death. 2018. The discovery of Alder B in Natural Science Journal. March 14, 2018. Hale's death. 2018. The discovery of Alder B in Natural Science Journal. March 14, 2018. Hale's death. 2018. The discovery of Alder B in Natural Science Journal. March 14, 2018. Hale's death. 2018. The discovery of Alder B in Natural Science Journal. March 14, 2018. Hale's death. 2018. The discovery of Alder B in Natural Science Journal. March 14, 2018. Hale's death. 2018. The discovery of Alder B in Natural Science Journal. March 14, 2018. Hale's death. 2018. The discovery of Alder B in Natural Science Journal. March 14, 2018. Hale's death. 2018. The discovery of Alder B in Natural Science Journal. March 14, 2018. Hale's death. 2018. The discovery of Alder B in Natural Science Journal. March 14, 2018. Hale's death. 2018. The discovery of Alder B in Natural Science Journal. March 14, 2018. Hale's death. 2018. The discovery of Alder B in Natural Science Journal. March 14, 2018. Hale's death. 2018. The discovery of Alder B in Natural Science Journal. March 14, 18. Hale's death. 2021. Funding for the Harbor City University Group ends. 2024. The project effectively stops. September 2025. American Science Review, frozen indefinitely. Gareth Vale, the money didn't come. Actually spent $4.5 million out of the promised $100 million. 4.5%. This is not the failure of one person or one idea. It is a structural problem of public science. When an announcement creates expectations that technical reality cannot justify within the stated time frame and for the stated money. Frontier Lightsail could have been an honest project with honest goals. We are studying interstellar flight technologies. This will take decades and cost orders of magnitude more than we announced. That is harder to sell to the media, but it is more accurate. Instead, a media explosion in 2016 and a quiet fading away in 2025. Let us look more closely at how Starshot appeared from inside the scientific community, because the media picture was heavily distorted. In 2016, most astrophysicists and physicists who understood the scale of the task reacted to the announcement with skepticism. Not publicly, not in headlines, but in private conversations at conferences. Why? Because the physics of a laser sail is one thing, practical engineering is another, and the gap between physically possible and technically achievable within this budget and timeframe was obvious to anyone working in the field. Nathan Crow of Kingsley University was one of the few high-level scientists who publicly supported Frontier Lightsail and joined its advisory board. Crow is known for his willingness to voice unconventional positions, and in this case his participation gave the project academic legitimacy. But even Crow, in his publications of 2017 and 2018, was cautious. He wrote about the possibility of a conceptual demonstration, not about a flight to Alder Centauri. Colin Drake, the project director, had real experience in the United Commonwealth Space Agency, including managing low-budget missions in the SmallSat series. He understood the difference between a proof of concept and a full mission. In a 2019 interview, Drake said, according to Orbital News Network, "We are working on the fundamental physical principles. The engineering solution is another decade." Another decade. Not another year, another decade. That is an honest assessment, but it contradicts the narrative of 2016, when people spoke of a launch within a few decades, implying perhaps 20 to 30 years. Stop. Here the important question is the nature of such projects. Is Frontier Lightsail useful even if it never sends a probe to Alder Centauri? The argument in favor, yes. Even partial funding of research into laser sails, nanoprobes, and material science produces knowledge that can be used in other contexts. Technologies developed for Frontier Lightsail may find applications in deep surveying of the Daystar system, in satellite technologies. The argument against. $4.5 million were spent in the context of inflated promises. That distorted the distribution of research effort. Groups worked on problems defined by Frontier Lightsail, rather than on those that would have been most productive for the advancement of science independently of the interstellar narrative. Both arguments are real. The final balance is unclear. Let's look at what happened to the other programs in the Frontier Horizons initiative to understand the context. Frontier Listen is a program to search for signals from extraterrestrial intelligence, SETI, with a budget of $100 million over 10 years. It was launched alongside Frontier Lightsail in 2016. It works. It publishes results. It conducts observations. It is a real, functioning scientific program. Frontier Watch is a ground-based program for observing exoplanets around the nearest stars. It works. It produces scientific results. Frontier Forum is an annual conference on SETI and related topics. It is held. That means 3 out of the 4 programs are functioning normally. Only Frontier Lightsail is frozen. Why Frontier Lightsail specifically? Because Frontier Lightsail is the only one of the 4 that requires engineering breakthroughs that do not exist. Listen, watch, forum. These are applications of existing technologies and methods to new tasks. That is feasible. Frontier Lightsail required the creation of an entirely new class of technologies. That is a different level of difficulty and a different level of risk. Mercer probably understood this, or his advisors conveyed that understanding to him, sometime between 2018 and 2021. The funding was redistributed, but there was no public announcement of that redistribution. That is the problem. Now about why it is important to close scientific projects publicly. First, resources. When researchers work on Frontier Lightsail tasks, they are not working on other tasks. If the project is effectively closed, but officially frozen, groups may continue spending time on directions that nobody else needs anymore. Second, the psychology of science. When a large, publicly announced project dies without acknowledgement, it creates an atmosphere in which it is hard to speak honestly about failures. A culture in which failures are silently swallowed is a culture that does not learn from failure. Third, trust in science. When Mercer and Hale announce $100 million for interstellar flight, it receives global media coverage. When the project quietly dies, one journal writes about it. The asymmetry creates a false impression of progress in the audience. Many announcements, unclear how many results. This is long-term damage to trust in science and its funding. What should have been done differently? Announce the real goals in the real budget, not $100 million for a proof of concept of interstellar flight, but several million to study the technological barriers, results in 5 years, then a decision on whether to continue. That is less media-friendly, but it is honest. When the barriers turned out to be higher than expected, that should have been announced publicly. A technical report should have been written. They should have published what they studied, what they understood, where they got stuck. This is the standard applied in government space programs, even if not always perfectly. It is the standard absent in private science when there are no mechanisms to compel transparency. Mercer is a private investor. He is not obliged to report publicly. It is his money. But when you invite Hale, call the project revolutionary, and receive global media coverage, you create public expectations. And when those expectations are not met, staying silent about the reasons is unethical toward the audience you drew in. That is exactly where the gap lies. Not technical, not scientific, a gap between the media promise and real accountability. Let's look at the broader context. What Frontier Lightsail says about the model of funding ambitious science in general. Frontier Listen, another program from the same Mercer portfolio, works. SETI with a budget of $100 million over 10 years. It has published results. It has conducted observations of several million stars. It has built public databases. It has brought in universities. That is because LISTEN uses the existing infrastructure of radio telescopes. It does not create fundamentally new technologies. It applies well-understood methods to new tasks. Frontier Lightsail required creating something that does not exist. That is a fundamentally different risk. The difference is not in the scale of ambition. The difference is between, can we do this, but expensively and slowly? And this does not exist at all, and we do not know how to create it. Listen is the first. Frontier Lightsail is the second. Harold Whitmore, Emeritus Professor of Astrophysics at Ashford University, one of the early participants in Frontier Lightsail. 100 million sounds like a lot of money. Pause. It actually isn't. That is exactly what he told a reporter from American Science Review in 2025. Names, dates, documents. April 12th, 2016, the announcement at Skyline Crown Observatory. August 2016, the discovery of Alder B in Natural Science Journal. March 14th, 2018, Hale's death. 2017, a powerful flare from Alder Centauri. 2021, funding for the Sydney Group ends. 2024, the de facto stop. 2025, Briarfield University and Northbridge Institute of Technology, an AI-optimized ultra-thin sail, one of the few real results. September 2025, American Science Review, The Quiet Death of Breakthrough Starshot. Vale. It drew attention to the dream. Now let's examine what exactly was studied within Frontier Lightsail and what results were actually obtained. Vale's group at Pacific Coast University at Fairhaven published a series of papers on laser-driven sail acceleration. The main publications were in Journal of Astral Engineering and Photonics Research Proceedings. The results? Theoretical calculations of the optimal sail shape, preliminary laboratory experiments with small sails in a vacuum chamber, estimates of the sail's thermal heating under irradiation. This is real science, high quality, but it is academic research, not an engineering prototype. A group at the Easton Institute of Technology studied the material science of ultra-thin coatings. Aluminum oxide, silicon nitrides, molybdenum disulfide. Which material reflects laser radiation better and withstands thermal load? Publications in Practical Optics Quarterly and Optics Frontier. A group at Westbridge University studied options for probe miniaturization, the light chip. The concept, an integrated circuit with a photoreceiver, transmitter, acceleration sensor, battery, all coin-sized and with a mass of about 1 gram. By 2019, a conceptual design without a prototype. A collaborative effort by several groups produced models of sail flutter and stability during acceleration. This is an important engineering problem. At 20% of the speed of light, a sail experiences aerodynamic loads as it passes through the thin interstellar gas. Instability in the sail could destroy the probe. The results? An understanding of the scale of the problem, several approaches to stabilization, mathematical models. Not a single prototype has been tested under conditions even close to real ones. For $4.5 million, that is a reasonable amount of work. But it is not a proof of concept of interstellar flight. It is the study of certain aspects of technological barriers. The gap between what was announced and what was delivered is obvious. It is interesting to look at what was happening in parallel with Frontier Lightsail in the field of laser propulsion, independently of Frontier Horizons initiative. In 2021, the U.S. Space Agency published the concept for Sunrider, a solar sail with an area of 1,600 square meters for a flight toward the Daystar. It was launched in 2026. This is a different scale and a different principle. Sunlight, not a laser. But it is a real spacecraft. In 2024, the Japanese Space Directorate launched Heliosail 2, the second solar sail. The first Heliosail 1, in 2010, successfully demonstrated sail propulsion in interplanetary space. Sail technology works. The scale is different. A solar sail accelerates slowly, over years, to a few kilometers per second. Not 20% of the speed of light, but it is a real technology with real results, unlike the laser sail of Frontier Lightsail, which remained conceptual. The question no one asks in public: if Adrian Mercer had spent the same $100 million on solar sails for deep space probes, we would have had real spacecraft by 2030. Not interstellar ones, but craft going significantly farther than existing missions. It would have been less media-friendly, but tangible. One specific aspect deserves attention: what Frontier Lightsail did to popularize the idea of interstellar flight. Before 2016, the subject was academic. A few specialized journals, the Starlane Interstellar Society as an organization, conferences with small audiences. After the Frontier Lightsail announcement, the topic entered the mainstream. Documentaries, podcasts, educational programs. Physics students began writing theses on laser sails. That is not a zero result. The ideas spread. People who had never heard of interstellar probes heard about them. Some of them became scientists, engineers. Was that worth $4.5 million and the gap in expectations? That is a question of values, not physics. One more aspect about Alder B must be added, one that emerged after the original publications and complicated the mission target even further. In 2017, an exceptionally powerful flare from Alder Centauri was recorded, an order of magnitude brighter than a typical one. The flare was so intense that even if Alder B has a magnetic field, a significant part of its atmosphere could have been stripped away by this single event alone. Flares occur roughly every 50 days. That means that over the 5 billion years of the system's existence, hundreds of billions of flares have occurred, each one a blast of X-ray and ultraviolet radiation hitting a planet 11 times closer to its star than Earthmere is to the Daystar. Models from several groups, published between 2017 and 2020, converge on the same conclusion. Without a strong magnetic field, the atmosphere of Alder B will not survive. We have no data on its magnetic field, but we do have data on powerful flares. Those are real. A probe that reaches Alder B in 20 years will most likely find an airless rock in a zone of lethal radiation. That does not make the flight meaningless. That in itself would be revolutionary. But the search for conditions for life, as the main narrative of 2016, was an optimistic assumption that by 2020 had become significantly less likely. Adrian Mercer and Martin Hale announced a search for life. In 4 years, science clarified, life there, in the familiar sense, most likely does not exist. The project continued to exist at the level of meetings and small grants. Compare this with the U.S. Space Agency Deep Frontier probe, a specific, real program being developed in parallel. The Deep Frontier probe is not going to another star. It is going to interstellar space. The goal? 1,000 astronomical units, several times farther than the Pathfinder probes. That is about 1/100th of a light year. Launch is projected for 2036 to 2038. Cost, $3 to $4 billion. On board, real instruments to measure interstellar plasma, dust particles, magnetic fields, neutral atoms, photons of the cosmic background radiation. This is not media-friendly. Interstellar medium is not as thrilling a headline as "We are flying to another star." But this is real science, real data, a real instrument. Iterative engineering based on existing technologies. That is how real science moves forward, not through PR announcements with numbers that are never fulfilled. That is the contrast Frontier Lightsail creates, not through failure, but through comparison with alternatives that are less media-friendly and more real. The U.S. Space Agency Deep Frontier Probe program is a real initiative, not to another star, to interstellar space. A probe meant to travel 1,000 astronomical units, several times farther than the Pathfinder probes. Launch possibly in 2036 to 2038. Cost estimated at $3 to $4 billion. That is realistic. It is not Alder Centauri. It is the interstellar medium at a distance of up to 150 to 200 astronomical units. But it is real science, real data, a real instrument. In the context of this project, Frontier Lightsail looks like a PR campaign pointed in the same direction, but without a realistic plan for getting there. The Deep Frontier probe is being developed on the principle of iterative improvement of existing technologies. Radioisotope generators for power, a nuclear rocket engine for acceleration, existing communications technologies. Everything from what already exists, just farther and for longer. This is the difference between two approaches to the same idea. Let us consider one technical issue that rarely surfaced in public discussions of Frontier Lightsail, the question of targeting. When a probe flies for 20 years at 20% of the speed of light, any error in its initial direction is multiplied across an enormous distance. A deviation of 1,000th of a degree at launch becomes a miss of thousands of kilometers by the time it reaches Alder Centauri. For a successful flyby of Alder B, a planet presumed to be about 12,000 kilometers in diameter, orbiting several million kilometers from its star, you need targeting accuracy orders of magnitude beyond what any existing system can provide. This is not the main barrier. It is theoretically surmountable through active course correction using tiny thrusters aboard the probe. But active course correction means energy. It means mass. It means added complexity for a gram-scale nanocraft. Every solution to one problem creates new problems. This is called systems engineering, and it is precisely here that projects of this scale collide with reality. The laser array also demands extraordinary precision. To keep the laser spot fixed on a sail a few meters across, from a distance of 1,000 kilometers on Earthmere, while the sail is accelerating, would require an adaptive optics system that does not exist at the necessary scale. This is technically solvable in principle, but not in a few years, and not for a few $1 million. In his papers from 2016 to 2017, Gareth Vale described these barriers quite honestly. But the press conference at the Skyline Crown Observatory created a different impression. That a solution was near, that money could solve the problem. Money solves a problem if the problem is engineering. If the problem lies in fundamental physics, or in the absence of the necessary materials, money merely buys research time, not a guaranteed result. This is an important distinction, and it is one that gets lost in media coverage of major technological announcements. So the final question for Frontier Lightsail as a story is this: what exactly does it tell us about the model of private funding for ambitious science? Adrian Mercer is neither the first nor the last. Graham Foster funds Sky Foundry and its ambitions for the pale moon. Logan Pierce funds Orbital Forge and Mars. Simon Hartley funded Celestial Voyages. Victor Lang funded Eastern Private Space Ventures. All these projects share certain traits: a major media announcement with a large number attached, ambitious declared goals, and implementation that proves far slower and more expensive than originally announced. Orbital Forge, however, is a real success. Raptor 9 reduced launch costs by an order of magnitude, Wyvern really does fly to Orbital Station Alpha. SkyMesh really does work. Pierce, too, announced unrealistic timelines. Mars by 2020, SwiftTube within a year, but the technological base turned out to be real. Frontier Lightsail differs from Orbital Forge in one fundamental way. It had no real technological base from which iteration could begin. It was a pure concept. Orbital Forge began with existing Firecrest rocket engines and improved them gradually. That is the difference between "we need a new engine" and "we need new physics." The first is an engineering task. The second is a scientific dream. Frontier Lightsail was a scientific dream. Dreams are necessary, but when a dream is presented as an engineering project, it misleads the audience, even if unintentionally. Let us consider another technical barrier that rarely makes it into media retellings: the problem of collisions with dust. At 20% of the speed of light, every collision with a particle 1 micrometer across delivers an energy impact on the order of a megajoule per square centimeter of cross-sectional area. Interstellar space contains dust and hydrogen atoms. According to calculations, every square centimeter of the sail will encounter roughly 1,000 such particles during the journey. That means the sail must either survive those impacts or the probes must be launched by the hundreds, with losses accepted. The Frontier Lightsail concept assumed the second option: 1,000 probes at once. A few dozen might make it through. That changes the economics. The laser array, the main expensive element, is built once and used many times. The probes are mass-produced. This is intelligent engineering logic, but implementing it requires the development of mass production technologies for gram-scale probes and a laser array capable of repeated operation without degradation. Neither problem has been solved. Dust collisions are also a material science problem for the sail itself. That is exactly what groups at the Easton Institute of Technology worked on: silicon nitride, aluminum oxide, molybdenum disulfide. The search for a material that could survive bombardment. There has been progress. Silicon nitride, only a few nanometers thick, proved promising, but this is still far from a ready solution. And that is what the $4.5 million actually bought: an understanding of the scale of the task. Not a solution, an understanding. That is exactly what a proof of concept was supposed to do. And it did. The problem was simply that instead of proof of concept, the public expected the beginning of a project to the stars. The gap between those expectations is a communication problem, not a scientific one. This is not only the story of Frontier Lightsail, it is the story of what happens when a public dream meets engineering reality, and no one takes responsibility for honestly reporting that encounter. Silence is more convenient, but silence teaches nothing. Every major announcement in science creates a debt to the audience, a debt of results, or a debt of an honest explanation of why there are no results. Frontier Lightsail has not repaid that debt. Perhaps it still will if the promised report appears. For now, it has not. Let us look at one final question. Why launch such projects at all if the technology is not yet ready? That is exactly what moonshots do. They do not necessarily reach the pale moon, but they pose the question. They draw attention and money toward a direction. The Hudson Project created the atomic bomb in 3 years because it had money, people, and a clear engineering objective. Frontier Lightsail was not an engineering project. It was a research project. Those are different things, and they must be handled differently. The honest way to launch something like Frontier Lightsail would sound like this: we do not know how to do this. We want to pay smart people to figure out what would be required. In 10 years, we will tell you what we learned. That would have been accurate. Instead, it was 20 years to Alder Centauri. It was beautiful. It drew attention. It brought physicists to conferences. Some of them did real science. The result was not useless, just not the one that had been promised. Interstellar flight remains possible. Physics does not forbid it. Engineering is not ready. The money did not come. Those are three separate facts. That is the boundary between science as a tool of understanding and science as a PR product. 4.5 million out of 100 spent over 9 years is not a funding failure. It is a precise illustration of what a proof of concept for technologies that do not exist looks like in real money. Let's sum it up. Frontier Lightsail was announced on April 12, 2016, at the Skyline Crown Observatory in Kingsport. Adrian Mercer, Martin Hale, Ethan Calder, three names for maximum media reach. 100 million for proof of concept of interstellar flight. Actually spent 4.5 million, 30 contracts, 8 years. In 2025, frozen without an official announcement. A report was promised and never appeared. The technical barriers: a 100 gigawatt laser, a nanosond of 1 gram or less, an ultralight sail, military regulation, communication across 4 light years. None of them has been overcome. The target, Alder B, probably does not have the conditions for the life we are looking for. Powerful flares every 50 days, and most likely no atmosphere. Martin Hale died in 2018 without seeing progress. Adrian Mercer continues funding other Frontier Horizons Initiative programs: Frontier Listen, Frontier Watch, Frontier Forum. Frontier Lightsail is mentioned only in passing on that list. Colin Drake, by email: the project is on pause. The report promised by spring 2025 never came out. So what did Frontier Lightsail actually do? Gareth Vale: if you had to describe in one sentence what Breakthrough was and what it did, it drew attention to the dream. That is an honest conclusion. Not a revolution in spaceflight, not a billionaire's failure. Just this: the dream received media attention. Young physicists worked on sails. Silicon nitride became a little better understood. Meetings brought together people who were thinking about interstellar flight. That is too little for the 100 million that was promised. It is enough to say that the 4.5 million was not spent entirely in vain. An open question. 4.5 million out of 100 was spent. Martin Hale is dead. There has been no official announcement. Laser sail technology is real. The physics works. But the scale required, $5 to $10 billion in several decades, is fundamentally different. Interstellar flight remains possible. This path toward it was quietly closed. Is there a way to announce that honestly? And who should do it if a private organization is accountable to no one? This is not only a question about Frontier Lightsail. It is a question about how public science works when private money and private decisions stand behind it. For now, the silence remains unbroken. That is what should have been announced. The dream has been brought in. The task has been formulated. The barriers are understood. The money is insufficient. The next step belongs to governments or to a new consortium. Next video: Holloway Void, the Silver River Galaxy